So hi and hello. Welcome to our channel named LU Exploration. My name is Samir and in today's lecture we are going to see how to rotate an array for the k number of time. But before that, let me say one thing, that we have started a series on solving the DSA problems. If you haven't watched it yet or access them, I highly recommend that please watch the playlist. The link is in a description box. Now, this series is very important for you if you are preparing for interviews and placement purpose. If you know the fundamentals of DSA, but you are stuck in solving the problems of DSA, then this series is for you. Okay, so again, the link is in the description box. Now, let's start with this question: rotating an array for the k number of times. Okay, so what do you mean by this? Now, if we have an array 14, 14, 67, 23, 89, 45, 12, 78. So let's say I want to rotate it for the one time. So k will be 1. Now this 78 will be at the first. So 78 will come here and all the remaining elements will be shifting on the right hand side. So 14 will come here, 67, 23, 89, 45 and then 12. Okay, I want to rotate it once again. So k will be 2, 1 and then 2. Okay, so 12 will come first. So 12 will come here and all the remaining elements will be shifted on the right hand side. So 78, then 14, 67, 23, 45. Okay, 23, then 89 and then 45. Again, let's rotate it for the last time. So 45 will come first, then 12, 78, 14, 67, 23 and then 89. Okay, so this will be the resultant array if the value of k is 3. Okay, now what I'll recommend, that take a pause, try to do it yourself. If you are stuck for solving this question, then you can watch my video. Okay, now let's take original array 14, 67, 23, 89, 45, 12 and 78 and the resultant array, which is this one. Okay, so 45, 12, 78, 14, 67, 23, 89. Okay, so this is the original array and this is the resultant array. Okay, now if we observe this, we can see that the last three elements of the original array is getting stored in the first three indexes. All right, 45, 12, 78 and so on. Similarly, the first four element is getting stored in the last four indexes, right? So what we can do, we can take one new array. Okay, and then we can store these three elements, the last three elements, in the first three indexes of the origin of the new array and the first four elements in the last four indexes of the new array. Okay, now let's see how we can do this. Now what I'll be doing here, I'll be taking these four elements first. Okay, and storing it in the last four indexes. Okay, so let me give the indexes: 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay, now if we observe, I want to store the element present at 0th index in third index of B. Similarly, element of present at first index should be present or stored at index 4. 2 will be storing in 5 and 3 will be getting stored in 6. So what I'll do here, I'll simply put I here, but I want to figure it out what should be here. Now we know that the value of k is 3, right? So what I can do, I'll simply do I plus k. That's it. Okay. So when the value of I is 0, we know that the value of k is 3. So 0 plus 3 will be 3. 1 plus 4, 1 plus 3 will be 4. When the value of I is 2, so 2 plus 3 will be 5. When the value of I is 3, 3 plus 3 will be 6. Okay, so the first for loop will look like this. For I will be running from 0, right? But now we want to figure it out. What should be the condition, right? I should be less than what? Let's see. See, the value of 3 is k, and we want to store the 4 elements here, right? 3 elements will come here, and the remaining elements will be getting stored, right? These are the remaining elements. So what will be the remaining elements? If my array size is n, I am subtracting k elements, so this will be the remaining elements, right? So the condition will be I should be less than n minus k. That's it. All right. Now I want to store a of i in b of I plus k. That's it. So using this for loop, we will able to store the n minus k elements in this indexes. That means the first 4 elements in the last 4 indexes of the new array. Okay. Now let's see how we can store the last 3 elements in this position. Now here also we have to observe this. The element present at index 4 should be stored in 0th index of new array. Element present at index 5 should be present in first index of new array. Similarly, for 6, it should be stored in 2. So here also what I'll do, I'll simply have an I. Now we have to figure it out what should be present here, right? Now, since the value of 3 is k, what I'll do, the remaining elements will be n minus k. All right. I'll simply put plus I. That's it. So n minus k plus I. So n minus k will be 4. 4 plus 0 will be 4. 4 plus 1 will be 5. 4 plus 2 will be 6. That's it. So the new for loop, then another for loop will look like this. For I will be running from 0. Here we can see that we have to only run for three times, right? Because we are storing the 3 elements, right, in these indexes. Why 3? Because the value of k is 3. So I will be running for 0 to k. That's it. Now in b of I want to store a of element present in a of n minus k plus I. Right. Now if we take a look here, the for loop is running for n minus k time. Here the for loop is running for k times. So it will be n minus k plus k. So that will be this, and this will get cancelled. So it will be order of n. So the time complexity for this program, for this code, will be order of n, and the space complexity, try to comment it. What might be the space complexity here? The space complexity will be order of n. Okay, why order of n? Because we have taken the extra space, that is b. Okay, now this is approach 1. Now the approach 2 will be, we have to solve this question without taking the help of this extra space. Okay, now let me take the original array and the resultant array, because here also we need to have some observations. So this is the original array. If we rotate it for the 3 times, then it will look like this: 45, 12, 78, 14, 67, 23, and then 89. Right? Now this is the original array and this is the resultant array. Okay. Now let's see one thing. For the time being, let's try to reverse this part. Okay, let's try to reverse this part. Now, if you don't know how to reverse an array, I highly recommend to please watch my previous lecture on how to reverse an array. Okay, the link is in the description box. So 78 will come first, then 12, then 45. Also, let's try to reverse this part. So 89, 23, 67, and then 40. Now, if we try to observe this rotated part of this and then this with this. Now, if we try to compare, we can see that this is nothing but a reversal of this, right? Or we can say that this is nothing but a reversal of this, right? So, what we can do, if we reverse the original array, we'll be getting this, right? We'll be getting this. Then we will take the first 3 element and try to rotate, try to reverse it. So we will be getting this. Similarly, we will be reversing the next n minus k element. Okay, so we will be getting this. So that's it. In this 3 part, we will able to solve the whole question. The first step will be reverse the whole array of size n. The second step will be simply reverse the first k elements. Okay, after reversing the whole array. Okay, then the third will be reverse the next n minus k elements. Okay, so in these 3 simple steps, we will be able to solve this question. So I hope you know that how to reverse an array. Okay, so I'll be simply putting here the function name. So reverse array. Here we will be passing the original array and the indexes. So 0 will be the first index and then n will be the last index. We will be just taking n minus 1. Okay, so reverse array. So here we are reversing the first k element, 0 to k. Again reverse array. Here we are reversing the next n minus k element. Okay, so if we observe, this function will take n time, this function will take k time, and this function will take n minus k time. Now if we do the summation, it will be n plus k plus n minus k, right? So this and this will get cancelled, so it will be 2n. Therefore the time complexity will be order of n. Similarly, what might be the space complexity here? The space complexity will be order of 1 because we didn't take any extra space. So in this way, we can solve the problem. Now, let's take one more example. I want to show you something. 11, 12, 15, 33, and let's take 5. Okay. So index were 1, 0, 1, 2, 3, 4. Now I want to rotate it for, let's say, 5 times. So k will be 5. Let's rotate it for the one time. So it will be 5, and this elements will come in, right? Let's rotate it for 2 times. Then 33 will come here, and these elements, all the remaining elements will come here, right? So k will be 3. So 15 will come here, and 33 from 5, 11, 12. K will be 4. So 12 will come here, and then 15, 33, 5, and 11. Let's rotate it for the last time. K will be 5. So 11 will come here, then 12, 15, 33, and then 5. Now, if you observe, when k equals to 5, which is actually the length of an array 5, you can see that these are equal. Even if you do k equals to 10, even if the value of k is 10, that is nothing but the multiples of length of an array, answer will be always the original array. So the giveaway for this will be when k is equals to 0 or multiple of length, return original array. Don't do anything, but let's try to rotate it one more time. Here k here k is equals to 6, so 5 will come here, then 11, 12, 15, and then 33. Now when we rotate it for the one time and when we rotate it for 6 times, these are also equal, right? So if we rotate for one time, then it is equals to rotating it for 6 times. If we rotate for 2 times, it is equals to rotating for 7 times. Similarly, 11, 12, right? And so on to say. I hope you understand what I'm trying to say. If you rotate it for 6 times, it's equals to rotating it for 8 times and equals to rotating it for 13 times. So in the question, if k is equals to 12, let's say, so it is actually meaning that rotate it for 2 times only. Then how do we get it? So what we will do, k equals to k mod length, right? So let's take one example. Let's say we want to rotate it for 13 times. So 13 mod 5, because here the length is 5. So 13 mod 5 is nothing but 3, right? So the meaning is this, that rotate it for 3 times. That's it. So in the program, you have to first of all find out the length of an array, then do k equals to k mod length. So these two lines you have to write it extra. Now now let's jump to our coding part. Here we are going to code how to rotate an array. Okay, so don't worry, I'll be putting the link of this problem in the description box so that you can practice. Okay, so this is the same question only. Now let's first initialize the length. Int length is equals to nums dot length. Now here the value of k, first we have to check whether the k is not equals to length. If it is, then we are actually returning the same array only. So the value of k is k mod length. If k is equals to length, then simply return. No need to do anything now. But if k is not equals to length, then at that time we have to reverse it. So reverse the whole array first. So I am creating a function called reverse array in which we are passing the nums original array, the starting index and the ending index, that is length. After that, we have to reverse the first k elements, right? So nums, the starting index will be 0 and the ending index will be k. Now we have to reverse the next n minus k element, right? So nums, the starting index will be k and the last index will be length, right? Now let's try to create the reverse array function. So public void reverse array, your first parameter will be array, then start here, then end. Okay, now I'm going to take two new integers I and j. So int I, this will be the start, and j, this will be the end minus 1, right? I hope you know that how to reverse an array. If you don't know, I highly recommend that. Please watch my video. The link is in the description box. Now, while I should be lesser than j, now here we have to swap the elements present in a of I and in a of j. So arr I comma j. After that, we have to increment our I and decrement the j. So actually you can swap here only in the while loop, but I like to have another function. So public void swap, inside this the array int I and int j. So first we will create a temporary variable in which we are going to store array of a of I. Okay, now after that in array of I we are going to put array of j. So actually I have a habit of calling array as a. So actually when I'm saying array, it means a only, or when I'm saying a, it means array. Now a of j, in a of j we have to store temporary value. Okay, that's it. So let's try to see whether we are getting some error or not. Okay, so nums, so k mod length correct. Okay, let's try to compile this again. Okay, now it's passing these two test cases. Let's try to submit. Okay, so you can see that it is actually passing all the test cases. Okay, so in this way you can solve this problem. Okay, so thanks for watching and please subscribe for more such videos.